This is problem number 23 from the 2020 AMC10B and number 19 from the AMC12B. The problem reads, square ABCD in the coordinate plane has vertices at points A, 1, 1, B, negative 1, 1, C, negative 1, negative 1, and D, 1, negative 1. Consider the following four transformations. L, a rotation of 90 degrees counterclockwise around the origin. R, rotation clockwise around the origin. H, reflection across the x-axis. And V, a reflection across the y-axis. Each of these transformations maps the square onto itself, but the position of the labeled vertices will change. For example, applying R and then V would send the vertex A at 1, 1 to negative 1, negative 1. And would send the vertex B at negative 1, 1 to itself. How many sequences of 20 transformations chosen from the set L, R, H, V will send all the labeled vertices back to their original positions? For example, R, R, V, H is one sequence of four transformations that will send the vertices back to their original positions. We can draw a graph of our square with A at 1, 1, B at negative 1, 1, C at negative 1, negative 1, and D at 1, negative 1. We can represent the square as ABCD in this notation, as the problem states that each of these transformations maps the square onto itself. We consider all four transformations from the initial position. We notice how the letter A seems to always be in one of these two positions as shown by the circles. We now try the transformations on this, giving us these transformations. So we can see that odd number transformations would give us this, while even number transformations give us this. Notice how A is either of the positions 2 out of the 4 times, meaning that there is an equal probability that we get either outcome. This logic can also be applied to B, C, and D for the probabilities of their transformations. 20 is an even number, so no matter what transformation 19 has, A will be either of these two positions with equal probabilities. This also applies to B, since C and D are determined by A and B. We don't need to generate any extra cases from their positions. Thus, 19 random transformations are possible in 4 to the 19 ways, and 4 transformations are possible for the 20th transformation with a 1/4 chance of giving us the desired outcome. Thus, we get 4th and 19th, or 2 to the 38th.